We're going to do a few more problems where we're going to use that vertex form of our parabola. So the first one is review. Find the vertex by completing the square. So remember, we want to factor out that leading coefficient, but just out of the x terms. So that will leave us with x squared minus 3x. I'm going to leave a space and push the minus 1 outside the parentheses. Now it gets a little tricky. We want to take half the middle term and square it. We don't really worry about the sign because once we square it, it's going to become positive. So half of 3 is 3 halves. 3 halves squared is 9/4. That is the number we're going to add into that parentheses is the 9/4. Now that 9/4 will be multiplied by that 2, which will make it a positive 9 halves. So to balance this, we're going to subtract the 9 halves. So now our equation is going to look like y equals the 2 that we factored out. We have now created a perfect square. It's going to be x minus, and we can either take the square root of that or half of the 3. So that's going to be 3 halves. We'll combine these values here. So -1 is -2 halves, so that'll make that minus 11 halves. That's vertex form, and our vertex, because we were trying to find the vertex, is going to be a positive 3 halves, comma, -11 halves. Okay? So now we're going to do a different kind of equation. We're going to find an equation of a quadratic function, and since we're given information about the vertex, that suggests that we are going to start with vertex form of our parabola. Now we're going to plug in. We know that the vertex gives us the h and the k, and a point is going to give us a value for x and y. So plugging those in, we're going to get -6 goes in for the y. We don't know the a, that's what we're going to figure out. The x is going to be 1. The h is going to be 2. We're going to square that and then add in that k, which is the -3. So from there, we're going to get -6 is equal to 1 minus 2 is -1. -1 squared is +1. So that's going to be a minus 3. So adding that 3 to the other side is going to give us the a. So now that we know the a, and we already knew the h and k, we can now get y equals, there's our a, x minus h is going to be x minus 2 squared. Whoops. Let me pull that back there. And then the plus k is going to be a minus 3, and there is our equation of our parabola. So the next one we're going to do similarly. So we're starting with the y equals a times x minus h squared plus k. The vertex gives us the h and k, and a point gives us a value for x and y. So we'll get y is going to be 3 equals the a we're going to try to find. The x is -1. The minus k is going to become a plus 3. We'll square that, and then we're going to add to that the 1. So taking care of the order of operations, inside the parentheses is 2. Exponent next is 2 squared is 4 times a plus 1. Subtract the 1 will give us 2 equals 4a. And so a is going to be 1/2. And so our equation is going to become y equals a, which is 1/2, x minus h will be a plus 3 squared, and then a plus 1 for the k. Very good. Let's do a different kind of problem. I'm going to stop here and write it out. It's a word problem. So we're going to build a pen using 100 feet of fencing, forming 2 side-by-side rectangles, and using the barn as one side as shown. And so what we're going to try to find is what are the dimensions of the fence with greatest area. So we know that we can consider this to be one big rectangle here, and we can see that one side is going to be x, and what we need is an expression involving x for the other side, because we know that that area of the rectangle, the thing we're trying to find the maximum of, is going to be length times width. So if you think about it, we have 100 feet of fencing, and we're going to subtract off 3 of those x's. The barn is going to form one side, so we're going to have 100 minus that 3x feet of fencing to build that other side of our pen. So the area then is going to become length times width, which is going to be x times 100 minus 3x. So our maximum value, this is, if we multiply this out, we're going to get 100x minus 3x squared. So we know that this is a parabola that opens down, so we can envision it looks something like that. Its maximum is going to occur at the vertex. And we know that the vertex we can find using negative b over 2a. So our b is going to be that 100, so we can go negative 100, and 2 times a is going to be a negative 6, so that's 100 over 6. So that's going to be, if we were imagining graphing that, that's going to be this right here is 100 over 6, or we can reduce that to 50 over 3. So that is going to be the x value in this parabola. And so that is going to give us 50 over 3, or if you like, let's see, 3 goes in there. I think 3 times 16 is 48, so we could also think of it as 16 2/3 if that's any more help. That's going to be feet, and that, remember, is going to be, that is one of our dimensions on our rectangle. The length of our rectangle is going to be that other dimension, and that's going to be this 100 minus 3x. So that's going to be 100 minus 3 times our 50/3 is what we said was the x. So that's going to be 100 minus 50, or 50 feet. So our dimensions are going to be 50 feet by 16 2/3 feet. That's going to be the dimensions of our pen with largest area. I'm going to do one more kind of tricky question. See if we can do a little review in a different form. Can we put into standard form? Standard form, vertex form. Keep trying to put the parentheses in there too quick. And factored form, the following parabola, believe it or not. So we have y equals negative 6 plus x squared minus x all over 2. So that is a parabola because you have an x squared as the highest power of x. So let's see what we can do with this. Let's see if we can split that apart a little bit. So we can write that as negative 6, and we could call that x squared over 2, and then a minus x over 2, because they still have the same common denominator. If we rearrange that a little bit, we can put the x squared term first, and x squared over 2 is 1/2 x squared. The minus x over 2 is 1/2 x, and the minus 6. Now that is our form y equals ax squared plus bx plus c. So that is going to be our standard form. So let's see if we can maybe try to put that in vertex form. So if we do that, if you remember, we're going to factor that 1/2 out of the x terms. We'll leave the minus 6 over here. So factoring out that 1/2 will leave us with an x squared minus x, and I'm going to leave a space for that half the middle term squared. So the middle term is -1. I'm not going to worry about the negative. Half of 1 is 1/2. Squared is going to be 1/4. So we are going to add in here a 1/4. That 1/4 will get multiplied by a half. That makes that 1/8 that we've added to that side of the equal sign. So we're going to turn around and subtract it back off. So in vertex form, we're going to get y equals 1/2. Now we have built this so that this is going to be x minus half of that middle term is going to be a 1/2 squared, and then we can leave that as a -6 1/8, or call it 49/8. Either way, that is going to be our vertex form. Now, to find the factored form, we need to find out the factors of this thing. So if we have our 1/2 x squared minus 1/2 x minus 6, let's set that equal to 0. If we multiply through by 2, that's going to be x squared minus x minus 12 equals 0. I think we can factor this. You can use your box and diamond, or if you know how to do the guess and check, either way, we're going to get to x minus 4 times x plus 3. Now, you have to think a little carefully. This part, if I can keep my pen together, this part right here matches this right here, which we multiplied by 2. So to go from this version, the x squared minus x minus 2, to here, we're going to have to multiply by a half. So our factored form is going to have that 1/2, and then x minus 4, x plus 3. Whew, that was tough. That is our factored form. Very good. Hopefully you can do homework number 19.